The application of relay in electrical/electronics. Relays are versatile devices commonly used in various applications across industries. Here are some of the key applications of relays. In industrial automation, relays are essential components that facilitate the control and operation of various machinery and processes. Here's how relays are used in industrial automation. Control of motors and actuators. Relays are commonly employed to control the operation of motors and actuators in industrial machinery. They enable the switching of power to start, stop, or reverse the rotation of motors, allowing precise control over the movement of equipment such as conveyor belts, pumps, valves, and robotic arms. Process control. Relays play a crucial role in regulating industrial processes by controlling the operation of heaters, coolers, solenoid valves, and other devices. They help maintain optimal operating conditions, such as temperature, pressure, and flow rates, in manufacturing processes such as chemical processing, food production, and material handling. Safety interlocks. Relays are integrated into safety systems to implement interlocks and emergency shutdowns, ensuring the safety of personnel and equipment in industrial environments. They monitor various safety parameters, such as overtemperature, overpressure, and overspeed conditions, and trigger appropriate actions, such as cutting off power or activating alarms, in case of abnormal situations. Sequence control. Relays are used to implement sequence control logic in industrial automation systems, allowing the sequential operation of multiple devices or processes. They enable the coordination of complex sequences of operations, such as assembly lines, packaging systems, and batch processing plants, to achieve efficient production workflows. PLC, Programmable Logic Controller, Interface. Relays serve as interface devices between PLCs and external devices in industrial control systems. They receive control signals from PLCs and actuate relays to switch power to various field devices, facilitating the execution of control algorithms programmed in the PLCs. Remote monitoring and control. Relays equipped with communication interfaces, such as Ethernet, Modbus, or Profibus, enable remote monitoring and control of industrial equipment and processes. They allow operators to monitor system status, receive alarms, and remotely adjust control parameters, improving operational efficiency and reducing downtime. Power distribution and protection. Relays are used in industrial power distribution panels to switch power between different electrical loads and protect circuits from overloads, short circuits, and faults. They help ensure the reliable and safe distribution of electrical power to equipment and machinery in industrial facilities. Energy management. Relays play a role in energy management systems by controlling the operation of energy-consuming devices based on demand and optimizing energy usage. They facilitate the implementation of strategies such as load shedding, peak shaving, and demand response to improve energy efficiency and reduce utility costs in industrial settings. Overall, relays are integral components in industrial automation systems, providing reliable switching, control, and protection functions that are essential for the efficient and safe operation of industrial processes and machinery. Relays play various critical roles in heating, ventilation, and air conditioning (HVAC) systems, contributing to their efficient operation and control. Here's how relays are used in HVAC applications. Control of heating and cooling systems. Relays are employed to control the operation of heating elements, air conditioning compressors, and fans in HVAC systems. They receive signals from thermostats or HVAC controllers and switch the power supply to these components on or off based on temperature set points or user preferences. Relays ensure precise control over the heating and cooling cycles, maintaining comfortable indoor temperatures. Fan control. Relays are utilized to control the operation of fans in HVAC systems, including supply fans, exhaust fans, and circulation fans. They switch the power supply to the fans based on demand, adjusting fan speed and airflow rates to meet heating or cooling requirements efficiently. Relays may also be used for multi-speed fan control, allowing users to select different airflow settings as needed. Safety interlocks. Relays are integrated into HVAC systems to implement safety interlocks and protect against overheating, refrigerant leaks, or other hazardous conditions. They monitor temperature sensors, pressure switches, and other safety devices, and activate shutdown sequences or alarms in case of abnormal situations to prevent equipment damage or ensure occupant safety. Thermostat interface. Relays serve as interface devices between thermostats or HVAC controllers and HVAC equipment in heating and cooling systems. They receive control signals from thermostats and actuate relays to switch power to heating or cooling components, facilitating the implementation of temperature control algorithms and user-set temperature schedules. Defrost control. In HVAC systems with heat pumps or refrigeration units, relays are used for defrost control to prevent ice buildup on outdoor coils during cold weather conditions. They activate defrost heaters or cycle the refrigeration system into defrost mode based on temperature or time settings, ensuring efficient operation and preventing frost-related issues. Zone control systems. Relays play a role in zone control systems for HVAC systems with multiple zones or areas that require independent temperature control. They enable the selective activation of heating or cooling components in each zone based on temperature requirements, allowing users to customize comfort settings and optimize energy usage. Economizer control. Relays are used in HVAC economizer systems to control the operation of outdoor air dampers and facilitate free cooling when outdoor air conditions are favorable. They receive signals from temperature sensors or HVAC controllers and actuate relays to modulate the position of dampers, allowing the introduction of outdoor air to reduce the need for mechanical cooling and improve energy efficiency. Remote monitoring and control. Relays equipped with communication interfaces, such as BACnet, Modbus, or Ethernet, enable remote monitoring and control of HVAC equipment and systems. They allow building operators or facility managers to monitor system status, adjust set points, and troubleshoot issues remotely, improving operational efficiency and reducing maintenance costs. In summary, relays are essential components in HVAC systems, providing control, safety, and automation functionalities that contribute to efficient and reliable heating, ventilation, and air conditioning in residential, commercial, and industrial buildings. Relays are essential components in automotive systems, serving various critical functions to ensure the safe and efficient operation of vehicles. Here are some key applications of relays in automotive. Power distribution. Relays are used for power distribution in automotive electrical systems, allowing the routing of electrical power to different components and subsystems such as lights, motors, and accessories. They help manage high-current circuits safely, protecting sensitive electronic components from damage due to overloads or short circuits. Starter motor control. Relays play a crucial role in controlling the starter motor in automotive engines. When the ignition key is turned, the relay receives a signal from the ignition switch and closes contacts to supply power to the starter solenoid, which engages the starter motor and cranks the engine to start. Headlights and lighting systems. Relays are employed to control the operation of headlights, fog lights, turn signals, and other lighting systems in vehicles. They allow the switching of high-power lighting circuits with low-power control signals from the vehicle's switches or lighting controls, ensuring proper illumination for safe driving. Power windows and door locks. Relays are used in automotive power window and door lock systems to control the operation of window motors and door lock actuators. They receive signals from the window switches or door lock controls and actuate relays to supply power to the respective motors or actuators, allowing the opening or closing of windows and doors. Fuel pump control. Relays are employed to control the operation of the fuel pump in automotive fuel delivery systems. They receive signals from the vehicle's engine control module, ECM, or fuel pump relay control module, and switch power to the fuel pump to maintain proper fuel pressure for engine operation. Cooling fan control. Relays are used to control the operation of cooling fans in automotive engine cooling systems. They receive signals from temperature sensors or the vehicle's engine control module, ECM, and switch power to the cooling fans to regulate engine temperature and prevent overheating. Wiper motor control. Relays play a role in controlling the operation of windshield wiper motors in automotive wiper systems. They receive signals from the wiper switch or wiper control module and actuate relays to supply power to the wiper motor, allowing the movement of wiper blades for windshield cleaning and visibility enhancement. Anti-lock braking system. ABS relays are used in automotive ABS systems to control the operation of hydraulic valves and pumps. They receive signals from the vehicle's ABS control module and actuate relays to modulate brake pressure and prevent wheel lockup during braking, improving vehicle stability and control. Engine control. Relays are employed in various engine control systems, such as ignition systems, fuel injection systems, and emission control systems. They help manage the operation of engine components and subsystems, ensuring optimal performance, fuel efficiency, and emissions compliance. Safety and security systems. Relays are integrated into automotive safety and security systems for functions such as airbag deployment, alarm activation, and immobilizer control. They help ensure the proper functioning of safety-critical systems and enhance vehicle security against theft or unauthorized access. Overall, relays are indispensable components in automotive electrical and electronic systems, providing reliable switching and control functionalities that are essential for the safe, efficient, and comfortable operation of vehicles. Relays play a crucial role in power distribution systems by facilitating the controlled switching and distribution of electrical power to various loads and circuits. Here's how relays are used in power distribution. Load management. Relays are used to manage the distribution of electrical loads within a power system. They can be employed to selectively connect or disconnect loads based on system requirements, operational priorities, or load-shedding strategies. By controlling the activation of relays, power distribution can be optimized to balance loads and prevent overloading of circuits. Circuit protection. Relays are integrated into power distribution panels and switchgear to provide circuit protection against overcurrent conditions such as short circuits and overloads. Overcurrent relays monitor the current flowing through circuits and trip contacts to interrupt power supply when excessive current levels are detected, preventing damage to equipment and minimizing downtime. Feeder control. Relays are used to control the distribution of electrical power to feeder circuits within a power distribution system. They receive signals from control systems or protective devices and actuate relays to switch power between feeders, allowing selective energization or de-energization of feeder circuits as needed for maintenance, repairs, or load management. Transfer switches. Relays are employed in automatic transfer switches, ATS, and manual transfer switches, MTS, to facilitate the transfer of electrical power between multiple power sources or between the utility grid and backup generators. They monitor the status of power sources and actuate relays to switch between sources seamlessly, ensuring continuous power supply to critical loads during power outages or maintenance events. Voltage regulation. Relays can be used for voltage regulation in power distribution systems to maintain stable voltage levels within specified limits. Voltage control relays monitor the voltage at distribution points and actuate relays to adjust voltage regulating devices such as tap changers or voltage regulators, ensuring consistent voltage supply to connected loads. Fault detection and isolation. Relays are utilized for fault detection and isolation in power distribution systems to identify and isolate faulty circuits or equipment. They monitor parameters such as voltage, current, and impedance and trigger alarms or trip circuits to isolate faulted sections, preventing cascading failures and minimizing downtime. Remote monitoring and control. Relays equipped with communication interfaces such as SCADA, supervisory control and data acquisition, or DMP3, distributed network protocol, enable remote monitoring and control of power distribution systems. They allow operators to monitor system status, receive alarms, and remotely operate relays to perform switching operations or implement control strategies, improving system reliability and operational efficiency. Smart grid integration. Relays play a role in the integration of power distribution systems into smart grid infrastructure. They support advanced functionalities such as demand response, distributed energy resource management, and grid optimization by enabling real-time communication and control of distributed energy assets and grid-connected devices. Overall, relays are essential components in power distribution systems, providing critical functions such as load management, circuit protection, voltage regulation, and fault detection that are essential for ensuring reliable and efficient distribution of electrical power. Relays are integral components in telecommunications systems, playing various roles in signal routing, switching, amplification, and protection. Here's how relays are used in telecommunications. Signal routing and switching. Relays are employed in telecommunication networks to route signals between different transmission paths or switch between multiple communication channels. They receive control signals from network equipment or communication protocols and actuate relays to establish connections, allowing the transmission of voice, data, and video signals between users or network nodes. Telephone exchanges. Relays historically played a crucial role in telephone exchanges for connecting calls between subscribers. Electromechanical relays were used to establish and release connections between telephone lines, enabling users to make voice calls and communicate over long distances. While modern telephone exchanges have transitioned to digital switching technologies, relays may still be used in certain applications or as backup systems. Amplification and signal conditioning. Relays can be used in telecommunications equipment for signal amplification and conditioning purposes. They may control the activation of amplifiers or signal conditioning circuits to enhance the quality and strength of transmitted signals, compensating for losses in transmission lines or improving signal-to-noise ratios. Protection and fault management. Relays are integrated into telecommunications systems to provide protection against faults and abnormal conditions. They monitor parameters such as signal strength, voltage levels, and temperature and trigger protective actions, such as isolating faulty equipment or diverting traffic to redundant paths, to maintain network reliability and prevent service disruptions. Multiplexing and demultiplexing. Relays can be used in multiplexing and demultiplexing applications to combine multiple signals into a single transmission channel or separate signals from a composite signal stream. They help optimize bandwidth utilization and facilitate the transmission of multiple signals over shared communication links, such as fiber optic cables or radio frequency (RF) channels. Cross-connect systems. Relays are utilized in cross-connect systems to facilitate the interconnection of communication lines or channels within a telecommunications network. They enable the reconfiguration of network connections, allowing operators to route signals dynamically and adapt to changing traffic patterns or service requirements. Remote site monitoring and control. Relays equipped with communication interfaces, such as Ethernet or SNMP, Simple Network Management Protocol, enable remote monitoring and control of telecommunications equipment and infrastructure. They allow network operators to monitor system status, perform diagnostics, and remotely reset or reconfigure equipment as needed, improving operational efficiency and reducing downtime. Fiber optic switching. In fiber optic communication systems, relays may be used in optical switches to route optical signals between different fiber paths or ports. They enable rapid and precise switching of optical connections, facilitating wavelength routing, network redundancy, and optical signal grooming in high-speed telecommunications networks. Overall, relays play a vital role in telecommunications systems, providing essential functions such as signal routing, switching, amplification, and protection that are necessary for the efficient and reliable transmission of voice, data, and video signals across communication networks. Relays are fundamental components in home automation systems, enabling the control and automation of various household devices and systems. Here's how relays are used in home automation. Lighting control. Relays are employed to control the operation of lights in residential buildings. They receive signals from light switches, motion sensors, or automation controllers and actuate relays to switch power to lighting fixtures, allowing users to turn lights on or off, adjust brightness levels, or create customized lighting scenes based on time of day or occupancy status. Appliance control. Relays are used to control the operation of appliances such as air conditioners, heaters, fans, and kitchen appliances in home automation systems. They receive signals from control interfaces or automation controllers and actuate relays to switch power to appliances, enabling remote operation, scheduling, and energy management features. Motorized window treatments. Relays are utilized in motorized window treatment systems, including motorized blinds, shades, and curtains. They receive signals from control switches or automation systems and actuate relays to control the movement of window coverings, allowing users to adjust natural lighting levels, enhance privacy, and improve energy efficiency. Security and surveillance. Relays play a role in home security and surveillance systems for controlling alarm systems, door locks, and surveillance cameras. They receive signals from sensors, keypads, or automation controllers and actuate relays to trigger alarms, lock or unlock doors, and activate or deactivate surveillance devices based on security events or user commands. Climate control. Relays are used in HVAC, heating, ventilation, and air conditioning systems for controlling thermostats, heating elements, cooling compressors, and ventilation fans. They receive signals from temperature sensors or automation controllers and actuate relays to regulate indoor temperature, humidity levels, and air quality, optimizing comfort and energy efficiency. Irrigation and landscape lighting. Relays are employed in automated irrigation systems and landscape lighting systems for controlling the operation of sprinklers, drip lines, and outdoor lighting fixtures. They receive signals from weather sensors or irrigation controllers and actuate relays to activate or deactivate water valves or lighting circuits, ensuring efficient watering schedules and enhancing outdoor aesthetics. Energy management. Relays play a role in energy management systems for monitoring and controlling energy usage in residential buildings. They interface with smart meters, energy monitors, and automation controllers to track energy consumption patterns, implement demand response strategies, and optimize the operation of energy-intensive devices for cost savings and environmental sustainability. Voice and mobile app control. Relays can be integrated into home automation systems that support voice control via virtual assistants, e.g., Amazon Alexa, Google Assistant, or mobile app control through smartphones or tablets. They enable users to remotely command and automate various home devices and systems using voice commands or mobile app interfaces, enhancing convenience and accessibility. Overall, relays are essential components in home automation systems, providing reliable switching, control, and automation functionalities that enable homeowners to enhance comfort, convenience, security, and energy efficiency in their living spaces. Relays play several critical roles in renewable energy systems, helping to manage and control various components to optimize energy generation, storage, and distribution. Here's how relays are used in renewable energy systems. Solar photovoltaic, PV systems. In solar PV systems, relays are used for various functions such as solar panel array control, inverter switching, and battery management. They receive signals from solar charge controllers or system monitoring devices and actuate relays to regulate the flow of electricity between solar panels, inverters, batteries, and the electrical grid or loads. Wind turbine systems. Relays are employed in wind turbine systems for turbine control, pitch adjustment, and braking. They receive signals from wind sensors, turbine controllers, or supervisory control systems and actuate relays to control the operation of turbine blades, adjust rotor pitch angles, or engage braking mechanisms to regulate turbine speed and power output. Energy storage systems. Relays play a role in energy storage systems, ESS, such as battery banks or energy storage inverters. They facilitate the charging and discharging of batteries, switch between different battery banks or storage units, and manage the connection of storage systems to renewable energy sources, loads, or the grid. Grid-tied inverters. Relays are integrated into grid-tied inverters used in renewable energy systems to convert DC power from solar panels or wind turbines into AC power compatible with the electrical grid. They receive signals from grid monitoring devices or power management systems and actuate relays to synchronize inverter operation with grid frequency and voltage levels, ensuring seamless grid integration and power quality. Off-grid systems. Relays are used in off-grid renewable energy systems to control the operation of standalone power sources such as solar panels, wind turbines, diesel generators, and fuel cells. They manage the switching between different power sources, regulate charging and discharging of batteries, and control the distribution of power to loads based on energy availability and demand. Microgrid control. Relays play a crucial role in microgrid control systems for managing distributed energy resources, DERs, within a localized grid network. They coordinate the operation of renewable energy sources, energy storage systems, and loads, and facilitate islanding or grid-connected modes of operation based on grid conditions or system requirements. Fault protection and isolation. Relays are integrated into renewable energy systems to provide fault protection and isolation mechanisms. They monitor electrical parameters such as voltage, current, and frequency and trigger protective actions, such as disconnecting faulty components or isolating sections of the system, to prevent damage and ensure safety during abnormal operating conditions. Remote monitoring and control. Relays equipped with communication interfaces, such as Ethernet, Modbus, or CAN bus, enable remote monitoring and control of renewable energy systems. They allow operators to monitor system performance, receive alerts for faults or anomalies, and remotely adjust operating parameters or switch between operational modes, improving system reliability and efficiency. Overall, relays are essential components in renewable energy systems, providing critical functions such as energy management, power conversion, grid integration, and system protection that are necessary for the efficient and reliable generation, storage, and distribution of renewable energy. Relays play a vital role in medical equipment, facilitating the control and operation of various electromechanical components and subsystems. Here's how relays are used in medical equipment. Patient monitoring systems. Relays are employed in patient monitoring systems for controlling alarms, indicators, and actuators. They receive signals from sensors, monitors, or control panels and actuate relays to trigger alarms for abnormal vital signs, activate indicator lights for status indications, or control the operation of devices such as infusion pumps or ventilators based on patient conditions. Diagnostic imaging equipment. Relays are integrated into diagnostic imaging equipment such as X-ray machines, MRI, magnetic resonance imaging, scanners, and CT, computed tomography, scanners. They control the operation of imaging components, such as X-ray tubes, magnetic coils, and gantry mechanisms, ensuring precise timing, sequencing, and safety interlocks during imaging procedures. Therapeutic devices. Relays play a role in therapeutic devices used for treatments such as radiation therapy, electrotherapy, and ultrasound therapy. They control the activation of treatment modalities, adjust treatment parameters based on patient requirements, and implement safety features to protect patients and operators from excessive exposure or incorrect operation. Laboratory instruments. Relays are used in laboratory instruments for controlling sample handling, mixing, heating, and analysis processes. They control the operation of pumps, valves, heaters, and motors in equipment such as centrifuges, incubators, chromatography systems, and spectrophotometers, ensuring accurate and reproducible experimental results. Surgical equipment. Relays play a role in surgical equipment for controlling surgical tools, lights, and operating room accessories. They control the activation of surgical instruments such as electrocautery devices, surgical drills, and robotic arms, ensuring precise and safe operation during surgical procedures. Patient bed and mobility systems. Relays are employed in patient beds and mobility systems for controlling motorized adjustments, positioning, and safety features. They control the operation of actuators, motors, and locking mechanisms in hospital beds, stretchers, and wheelchairs, allowing caregivers to adjust patient positions, transfer patients safely, and provide comfort and support. Life support systems. Relays are integrated into life support systems such as ventilators, defibrillators, and dialysis machines. They control the operation of life-sustaining functions, such as breathing assistance, cardiac pacing, and blood filtration, and implement safety interlocks to ensure reliable operation and patient safety in critical care settings. Patient transportation and monitoring. Relays are used in patient transportation systems such as medical carts and ambulances for controlling equipment power, lighting, and communication systems. They facilitate the integration of medical devices and monitoring systems into mobile platforms, enabling continuous patient care during transportation between healthcare facilities. Overall, relays are essential components in medical equipment, providing reliable switching, control, and safety functionalities that are critical for the accurate diagnosis, effective treatment, and compassionate care of patients in healthcare settings. Relays serve important roles in aviation and aerospace applications, providing reliable switching, control, and safety functionalities critical for the operation of aircraft, spacecraft, and associated systems. Here's how relays are used in aviation and aerospace. Flight control systems. Relays are integrated into flight control systems to manage the operation of control surfaces such as ailerons, elevators, rudders, and flaps. They receive signals from flight control computers or pilot inputs and actuate relays to control hydraulic or electric actuators, enabling precise and coordinated aircraft maneuvering during flight. Avionics systems. Relays play a role in avionics systems for controlling various aircraft systems and subsystems. They manage the switching of power and signals between avionics components such as navigation systems, communication systems, radar systems, flight instruments, and cockpit displays, ensuring proper operation and integration of avionic equipment. Engine control systems. Relays are used in engine control systems to manage the operation of engine components such as fuel pumps, ignition systems, and starter motors. They receive signals from engine control units, ECUs, or cockpit controls and actuate relays to control the flow of fuel, air, and electrical power to the engine, facilitating engine startup, operation, and shutdown procedures. Electrical power distribution. Relays are employed in aircraft electrical power distribution systems to manage the routing of electrical power between generators, batteries, and electrical loads. They provide overcurrent protection, load shedding capabilities, and backup power switching functions to ensure the availability of electrical power for essential aircraft systems and equipment. Emergency systems. Relays are integrated into emergency systems such as fire detection and suppression systems, emergency lighting systems, and emergency oxygen systems in aircraft. They control the activation of emergency equipment and systems in response to critical events such as fires, electrical failures, or cabin depressurization, enhancing passenger safety and survivability. Environmental control systems. Relays play a role in aircraft environmental control systems for managing cabin temperature, humidity, and pressurization. They control the operation of air conditioning units, ventilation fans, and pressurization valves, ensuring passenger comfort and maintaining optimal cabin conditions throughout the flight. Aircraft landing gear. Relays are used in aircraft landing gear systems for controlling the extension, retraction, and locking of landing gear assemblies. They receive signals from landing gear control units or cockpit controls and actuate relays to control hydraulic or electric actuators, enabling safe and reliable deployment and retraction of landing gear during takeoff and landing operations. Spacecraft systems. Relays are employed in spacecraft systems for controlling various subsystems such as power, propulsion, communication, and scientific instruments. They manage the switching of power, data, and commands between spacecraft components and payloads, ensuring proper operation and communication with ground control centers during space missions. Overall, relays are essential components in aviation and aerospace applications, providing critical switching, control, and safety functionalities that contribute to the safe and reliable operation of aircraft, spacecraft, and associated systems in challenging aerospace environments. Relays play a crucial role in security systems, providing essential switching, control, and automation functionalities to safeguard properties, assets, and individuals. Here's how relays are used in security systems. Intrusion detection systems, IDS relays are integrated into IDS for controlling various security sensors, such as door/window contacts, motion detectors, glass break detectors, and vibration sensors. They receive signals from these sensors and actuate relays to trigger alarms, activate security lights, or initiate recording on surveillance cameras in response to unauthorized intrusion attempts. Access control systems. Relays play a key role in access control systems for controlling the operation of electronic locks, door strikes, and gates. They receive signals from access control panels or credential readers and actuate relays to unlock or lock doors, grant or deny access to authorized individuals, and enforce security policies for entry and exit points. Surveillance cameras and video management systems. VMS relays are used in surveillance camera systems and VMS for controlling camera functions such as pan, tilt, zoom, and recording modes. They receive signals from control panels or software applications and actuate relays to adjust camera positions, focus areas of interest, or trigger recording based on security events or user commands. Alarm monitoring and response systems. Relays are integrated into alarm monitoring and response systems for controlling communication devices, such as sirens, strobe lights, and notification devices. They receive signals from alarm panels or monitoring stations and actuate relays to activate audible and visual alarms, alert security personnel, or notify emergency responders in the event of security breaches or alarms. Perimeter security systems. Relays play a role in perimeter security systems for controlling fence sensors, gate barriers, and vehicle access control systems. They receive signals from perimeter sensors or vehicle detection devices and actuate relays to trigger alarms, activate deterrent measures, or control entry/exit points to secure the perimeter of properties or facilities. Fire detection and suppression systems. Relays are employed in fire detection and suppression systems for controlling fire alarm devices, sprinkler systems, and smoke exhaust fans. They receive signals from smoke detectors, heat detectors, or fire alarm panels and actuate relays to trigger fire alarms, release fire suppression agents, or activate ventilation systems to manage smoke and heat buildup in the event of a fire emergency. Central monitoring and control systems. Relays are integrated into central monitoring and control systems for consolidating security information from multiple sensors and devices. They receive signals from various security devices, such as sensors, cameras, and access control panels, and actuate relays to display status information, generate alerts, or automate responses based on predefined security policies or user commands. Integration with building management systems. BMS relays are used to integrate security systems with building management systems for centralized control and monitoring of security, environmental, and energy management functions. They receive signals from BMS controllers or software platforms and actuate relays to coordinate security actions with building operations, such as adjusting HVAC settings, lighting controls, or occupancy schedules based on security events or occupancy status. Overall, relays are essential components in security systems, providing critical switching, control, and automation functionalities that are necessary for detecting, deterring, and responding to security threats effectively and ensuring the safety and protection of people and assets. Overall, relays are fundamental components in numerous electrical and electronic systems, providing reliable switching and control capabilities across a wide range of applications.